Hello everybody. Today's topic is electric field. So what is the electric field? The space around a charged body within which its influence can be felt is called electric field. Then what is the concept of electric field? So to understand the concept of electric field, we do a very simple activity. We take a source charge which is positive charge and a test charge Q naught is placed at point P. If a force F is exerted on the test charge, then we say that electric field exists at that point. Here the charge Q is called source charge as it produces the electric field, and Q naught is the test charge, and F the force experienced by test charge, and this force is exerted by source charge. So this was a very simple activity to understand the concept of electric field. Now we have to define the electric field intensity or electric field at a point or electric field strength E. The electric field or electric field intensity or electric field strength E at a point is defined as the force experienced by a unit positive test charge placed at that point without disturbing the position of source charge. Now let us suppose a test charge Q naught experiences a force F at that point P. Then electric field at that point, according to definition, we can write E equal to F by Q naught. Here test charge Q naught may disturb the charge distribution of the source charge and hence change the electric field E. So the test charge Q naught must be very small enough so that it does not change the value of E. So now we are going to define the electric field in this way. The electric field at a point is defined as electrostatic force per unit test charge acting on a vanishingly small positive test charge placed at that point. Hence we can write E equal to limit Q naught tends to 0 F by Q naught. Here Q naught tends to 0 means that on placing the test charge at the observation point, the source charge will not be disturbed. Electric field is a vector quantity whose direction is same as that of force F exerted on a positive test charge. Now coming to learn the concept of test charge. What is a test charge? It is a small positive charge which does not influence the other charges and by the help of which we determine the effect of other charges is defined as a test charge. So next topic to be discussed is electric field due to a point charge. Look at the figure very carefully. A point charge plus Q placed at point O and a test charge placed at point P. Its coordinate is x, y, z and the position vector is r and unit vector for the force on test charge is r. Unit vector r. We know that E equal to F by Q naught. So first of all we should know the force between these two charges. Now write the force in vector form like this. Now replacing the value of force in the equation F E equal to F by Q naught, we are getting 1 by 4 pi epsilon naught Q by RQ R unit vector R. R unit vector R is replaced by vector R because a vector is represented. A vector R may be represented like R unit vector R. Unit vector it is a unit vector along the direction of the vector r. So from this equation we can write the magnitude of electric field. Magnitude of electric field will be E equal to 1 by 4 pi epsilon naught q by r square. So what we have done in this equation? In this equation we have replaced the value of force, and force has been written in the vector form. So after writing the force in vector form, I have multiplied this equation by r. It is numerator and denominator is multiplied by r. Thereafter what I have done you can see, and finally we get the electric field, magnitude of electric field as E equal to 1 by 4 pi epsilon naught q by r square. Now we can have three components of electric field so easily, because we know that a vector may be represented in terms of its components. So vector E has three components along x, y and z axis, and vector E may be represented like EXI plus EYJ plus EZK, and vector R has also three components along x axis, y and z axis. So vector R may be represented like xi plus yj plus zk. Now from this equation we can see, in this equation we can replace vector r in terms of its component and unit vector, and E is also replaced, and thereafter we compare the coefficient of I, J and K. Finally we get electric field along x axis, electric field along y axis, electric field along z axis. You can see, look at the equation E equal to, I have written over here, and now when we compare the coefficient of I, okay, J and K, we get the three components of electric field along x, y and z axis. You can see once again how can we get all these. So right from the beginning you can see how can we get the components of electric field. Now coming to learn the electric field. Electric field in terms of position vectors of source, charge and observation point. Now first of all you will have to see this figure. This is a source charge, this is a test charge, position vector r dash and its position vector is r. F is the force exerted on Q naught by Q, and E is the electric field along the direction of F. Now you go through this equation, you know that E equal to F by Q naught, and F is replaced. First of all we write the force in vector form, and I have written all the things you can see, and you will get the value of force in terms of position vector. Now you replace the value of F in this equation, E equal to F by Q naught. You will get the final result in this way. So this was the electric field in terms of position vectors of source, charge and observation point. Go through it once again. Now, principle of superposition of electric fields. First of all, we should know what is the principle of superposition of electric field. According to the principle of superposition of electric fields, the net electric field strength at a point due to group of charges is equal to the vector sum of the electric field strength produced due to individual charges at that point. Okay, so we have n charges and we want to find the net electric field at point P due to all other charges. So I have written everything. You can see the charge Q1 and its distance is R1 from P, and the force F1 exerted by Q1, okay, and E1 is also along the direction of force. Now this force has its unit vector R1. Similarly, I have written for charge Q2, Qi, Qn, you can see carefully. For the charge Q2, the distance is R2 and unit vector R2 for the force F2. In the same way everything has been done, you can see, and now we have to use the principle of superposition of electric field. As per the definition, we can write resultant electric field at point P. At this point we have to write the resultant electric field, that can be written as E equal to E1 plus E2 plus E3 plus dot dot En, and this can be written in the form of summation. I have generalized in this way, I equal to 1 to n, and when you will put the value of I equal to 1, you will get E1, E2, E3. Okay, very simple. Now come to learn the electric field in terms of position vectors of source charge and observation point. Once again you have to see this figure very carefully. This is the observation point, its position vector is R, and charge Q1, its position vector R1, Q2, R2, Qi, Ri, Qn, Rn, and I have written the electric field for Q1, Q2, Qi, Qn, everything has been written. So in this case we are going to find the electric field in terms of position vectors of source charge and observation point. So once again we will have to use the principle of superposition of electric fields. Very simple. The net electric field at point P may be written as E equal to E1 plus E2 plus E3 plus dot dot En, or we can write in the form of summation. In this way we can write, and now the value of Ei in general term we can write in this way. In terms of position vector we know how to write, and look at the value of E1, electric field E1, E2, E3 in terms of position vector. Okay, so this was all about the electric field and different topics discussed. In the next topic we will discuss the electric field due to a circular loop of charge and electric field intensity at a point on the axial line of an electric dipole, which is also known as end on position, and one more position is there, that is broadside on position, will be discussed in the next class. Until then you revise it and go through it very carefully, try to understand and enjoy with physics. Thank you.